All right, everybody, welcome back. We are talking about solving equations by addition and subtraction. So we've got these equations like 5 plus x equals negative 23. And we're going to use addition and subtraction to solve that equation, to solve for x. And what I want you to keep in mind is that the goal in solving any equation, and I made a note here for you, that the goal in solving any equation is to get the variable. Our goal is to get the variable on one side all by itself. I know that 5 plus x equals negative 23. That's what it tells me. I don't care what 5 plus x equals. I just want to know what x by itself is equal to. And there's a couple of things. A lot of this today is review. In fact, all of this is going to be review for you. I know that you did this last year. If you went to a different school, you might have done it a little bit differently. However, every one of you has seen how to solve these problems. I just want to remind you a couple of things about why we're able to do that. So if I have, we'll just start with a basic example. We know that 11 is equal to 11. They're the same number. This side of the equal sign is exactly the same as this side of the equal sign. And I can change 11 a little bit. I can rewrite this and say that 11 is equal to 5 plus 6. I know that 5 and 6 added together is 11, which is still equal to this 11. Both sides of the equal sign are still the same. I can change that even more. I can say that 11 is equal to 5 plus 2 times 3. 2 times 3 is 6, plus 5 is 11, which is still equal to 11. So I'm manipulating this side of the equation a little bit, but I'm not changing the value. Everything still adds up and multiplies so that this side is equal to 11. But let's say, for example, in this one, that I don't want 5 anymore. I want to get rid of this 5. And so right now that 5 is sitting all by itself. So I can just subtract 5 from this side, and that makes that go away. And I'm just left with 2 times 3, which is 6. So now it doesn't equal the left-hand side. So I just need to remember I can do anything I want over here as long as I do it to the left side as well. I can do anything I want on one side as long as I do the same thing to the other side to keep it balanced, to keep it equal. So if I take 5 away from this side, I have to take 5 away from the other side. So 11 minus 5, it now becomes 6 is equal to 2 times 3, which we know is true. 2 times 3 is 6, so my left side and my right side are still the same. And I can keep going. I can divide by 3. I can multiply both sides by whatever I want, as long as I do the same thing to the right side as I do to the left, and vice versa. We use that idea to try and get the variable by itself. So in our example, we have 5 plus x equals negative 23. I don't want the 5. I want to get rid of it so that x is all by itself. Remember, that's our goal. So if you came here last year, great. You're going to have a little bit of a head start on the rest of the class that maybe went to a different school. But step one thing that we have you do just to help you keep the sides separate is to draw, we call them railroad tracks. You draw railroad tracks on each side of the equal sign. And really all I want you to do is separate the left and the right. That's all the railroad tracks does. It keeps your left and your right separate so you can make sure that when you do something on this side, you're going to also do it on the right. Okay? One thing you are going to need to get in the habit of doing, and it won't affect us very much today and tomorrow, but later this week and next week, it's going to make a big difference. Step 2, after you've done the railroad tracks, I want you to circle the variable. I want you to circle the variable and anything that is attached to it. Anything attached to that variable. And when I say anything, I mean the signs and the numbers in front of the variable or the fractions below the variable. And again, today and tomorrow, you're not going to see a lot of things with the variable. That's going to come into play a little bit more later, but I want you to get in the habit of doing it. So in this problem, the only thing that's with my x is a plus sign in front of it. So I've just got 5 plus x equals negative 23. Now, anything inside this circle, I can't get rid of until everything on the outside is gone. So I've got to get rid of that 5. And the way I get rid of that 5 is to use, we call them inverse operations. Right now, that's a plus 5. Even though it doesn't have a plus sign, we know that this means a positive 5. And I need to do the opposite of adding 5 because I want to get rid of it. And the only way to get rid of plusing 5 is by subtracting 5. So step 3 is to get the variable by itself by using inverse or opposite operations. Okay, so plus 5 is what's happening right now. I want to get rid of that 5, so I'm going to subtract 5 from the left. And that's going to make this go away. That plus 5 and minus 5 cancel each other out, and all I'm left with is an x, which is all I want on the left-hand side. We need to remember, though, if I subtract 5 on the left, whatever you do on one side, you must do to the other side. Okay, so if I subtract 5 on the left, I must do that to the other side. So I've got to subtract 5 on the right. So I've got negative 23, and I'm going to subtract 5 from that. We'll use our calculator just to practice using it a little bit. Negative 23 minus 5 is going to give me a negative 28. So x is equal to negative 28. And I'm done. X is all by itself, and I've got an answer on the other side. So I know that x is equal to negative 28. Step 4, we've kind of already done that. That's just solving for the variable. And again, today that kind of is blended in with step 3. Later, that's going to be a little bit different. And I just want you to get in the habit of going through these steps. Now, step 5 is what we practiced yesterday. I think that x is equal to negative 28, but just to make sure, I'm going to check my solution, okay? And I want you to check yours as well. I'm going to take this x and I'm going to plug it in up here. So I know that 5 plus x, and I think that x is negative 28. So 5 plus my negative 28 is, I want it to equal negative 23. So in my calculator, 5 plus a negative 28. And when I hit enter, I want it to say negative 23. And it does. So that means that this side is negative 23, this side is negative 23. They're the same, so I must have done my work correctly. Okay? Again, I know that's review for most of you. You've done this before, you've done opposite operations, you've done inverse operations. Some of you have done railroad tracks, others have done it different ways. The biggest thing I want you to take away today is this idea that I can do anything I want. The left and the right now they're exactly the same. So anything I want to do on the left, I can, as long as I do the same thing to the right-hand side. All right? So let's do these couple problems together. I'm going to go kind of fast. We're at 8 minutes already. I'd like to wrap this up by 10. So we're going to try and go a little bit quick. I've got g minus 16 equals negative 52. So step 1, I'm going to draw my railroad tracks to keep my sides separate. I'm going to circle my g. I'm not going to circle the negative because that goes with the 16. That minus goes with 16, not the g. And now I want to use inverse operations. Right now, g has a minus 16, and the opposite of minusing 16 is to add 16. So that's going to make this go away, but I have to do it to the right-hand side as well. So this becomes g. We better give it a tail so that you know that's not a 9. G is equal to negative 52 plus 16. I'm going to put it in my calculator for you. Negative 52 plus 16 is negative 36. That's what I think my answer is. I think my answer is negative 36. I'm going to plug it in to make sure. So where I see a G right here, I'm going to rewrite it as negative 36 minus 16. And I want that to equal negative 52. So negative 36 minus 16. When I hit enter, it equals negative 52, which is what I wanted. So I know that my answer is correct. I did good math. Number 2, negative 12 plus x equals 100. Railroad tracks, step 1. Step 2, circle the variable and whatever the sign in front of it and any numbers connected to it. And right now, it's just a plus sign. Excuse me. Now I've got to get rid of this minus 12. The opposite of minusing 12 is to add 12, which will make that go away. And now I need to add 12 to the right since I added 12 to the left. And I'm left with x is equal to 100 plus 12. You better not use your calculator. That's just 112. Now I'm going to plug it in and check my work to make sure I didn't make a mistake. So negative 12 plus, instead of x, I'm going to write 112, and I want that to equal 100. This one we can plug in the calculator. Negative 12 plus 112 equals 100. Okay? And again, that's what I wanted it to equal. So I did good math. I know that x is equal to 112. All right, number 3, and I'll let you on your way. I'm going over. Railroad tracks. Okay, circle the variable and anything in front of it or underneath it. So it's just an h, and then I have plus 20 that I want to get rid of, so the h is by itself. So I'm going to subtract 20 from the left, subtract 20 from the right. Those go away. I'm left with h equals negative 15 minus 20 is negative 35. I think that h is equal to negative 35. So I'm going to plug it back in. Negative 35 plus 20, I want that to equal negative 15. So we'll put negative 35 plus 20, hit enter, and it does equal negative 15, like I wanted it to. Okay? So I'm confident that this is the correct answer. I double checked my work. I know that the bridge isn't going to collapse, right? We talked about that yesterday. I feel comfortable with this answer. I'm going to do well on that test. So I want you to try these 3 problems on your own. Be careful of the signs. Be careful of the inverse operations. When you have minus 17, you want to do the opposite. Come show me what you've done. Make sure that you've got them correct, and I'll give you the practice for the day. Good luck.